Okay, so let's get started. We're going to be taking a look at how to set up our closed loop boost control in our Link G5 and G4X system. So this tutorial is going to be focusing on the setup and configuration for closed loop control. The next tutorial, we're going to get into actually working in the PID-based tuning and understanding how the control strategy actually works. Then we'll have another tutorial taking a look at closed loop boost control, looking at through some calibration file and log file examples so we can get a better feel for how the system works and what to look for in a data log to evaluate the closed loop system performance. What we're going to do right now is jump in and take a look at where we can find our closed loop boost control within our Link programming. We're going to move here from our fuel tuning page and go across here to our closed loop boost page. Let's go ahead and click on this right here. Now in our page, we have a lot of different parameters and variables to adjust. What we're going to do is just turn the system on. We're going to learn some of the basic details here, configuration details, and making sure we have things set up that put us in a position so that when we actually start to use the boost control, things will be in order and we can make logical sense going into the next tutorial, learning how to actually work with and tune the boost control system. So this is just a setup and configuration tutorial. Just as we looked at and talked about the drive-by-wire, setting all that up for the pedal and plate relationship and getting those TPS sensors configured and some of the background settings initiated before we did the PID tuning. That's how we're going to be doing this. We're just going to break this down and keep this as simple as possible and spread it across a couple of tutorials so you can go in and watch each individual topic. Okay, so what we're going to do right now is go up here to our boost setup under boost mode, and we're going to go here from off, and we have some options here. We can choose open loop, closed loop, dome pressure control, or disable. Now, when we choose open loop, but we looked at that in the last tutorial, that's not using any feedback from the Link to try to target ourselves to a specific boost pressure. So it's just going to be whatever you command for a duty cycle to the boost control solenoid, that's the boost that you're going to get. Link has amazing closed loop control, so we absolutely want to work with closed loop option whenever possible. Open loop, again, we've covered that already. Closed loop is what we're going to talk about in this training module. We also have dome pressure control. This is for CO2-based boost control with a twin boost solenoid. We're going to get into how this all works and the configuration for dome pressure control in another tutorial. The disabled option allows you to keep all of your tables and parameters visible on screen here. Without setting the off mode. Off means it's just off. So disabled means the system is disabled, but the tables and parameters you've programmed are still able to be viewed, and you can work with it. If you set it to off, it resets all of your settings in here, which definitely can be annoying. So disabled would be what you want to choose if you want to just turn the system off, but you don't want to have to restart going through all the table setup and configuration because that can take a little bit of time. I'm going to go here to close loop and select this option here for this tutorial. And then it's going to ask me, do you want to clear your boost target table values and set all your axes to default values? We're going to just say yes here, and the wastegate duty cycle, which is our table right here, we're going to say yes as well. We're going to learn how we can configure these tables. What I do want to do is just jump in here. Let's unlock our window right here, double click on our grid icon that brings in the boost target table here, and then we're going to go and unlock our wastegate duty cycle table, and then double click on the grid icon that brings the table live right here. So now we have our two tables that we can start to work with. These work hand in hand for the closed loop control. We're going to talk about prepping these tables for going through the tuning in the next tutorial. So we just bring them live on screen so we can take a look at this. So the next thing we have here is going to be our boost source. Now the boost source is going to be selection between either map pressure or a general purpose pressure 1 through 4. In the closed loop control, when we're talking about a 3 or a 4-port boost control solenoid, we're going to be using map pressure as our option. The general purpose pressure is intended for using CO2-based boost control, that dome pressure control. So we're not going to select any of the general purpose options. We're only going to select map pressure as our option here for closed loop control because we're trying to control at a specific boost pressure. Let's go ahead and click OK here. Now the pulse width modulated output, this is going to be taking a look at this, assigning how we're controlling the boost control solenoid. So on a MAC 3-port boost solenoid, we're going to have 2 wires. One wire is going to be 12-volt power to the solenoid, And then the other wire is going to be our control wire. We're going to be pulsing it in a low side fashion, just like a fuel injector. And that's going to be energizing the solenoid to allow more or less boost pressure to flow through the solenoid to achieve a certain desired amount of boost. We're going to talk about the routing and configuration for the vacuum and pressure lines in just a minute for looking at 3-port solenoids, controlling internal external wastegates. But we need to choose an output we're going to be working with here from the link to control that single wire that we're pulsing in a low side fashion to the boost control solenoid. I'm going to use aux3 here from my Link G5 box and click OK. Now the aux test, this allows you to send a test output to the control solenoid, which isn't necessarily a bad idea. That'll allow you to hear if that solenoid clicks and buzzes when you go here and run your test. So you can see if you choose on PWM, that'll go ahead and start to pulse that solenoid. It'll sound like a buzzing sound if the solenoid circuit is correct, meaning we have 12-volt supply and we're controlling and low side pulsing to the solenoid. So I don't need to test it right now, but you could to verify your wiring is correct to your solenoid. The activation state is important. We want that set to low. We want a low side control. We're pulsing in a low side fashion to that boost control solenoid because we've supplied the other leg or wire of the solenoid to 12 volt. Now there's no polarity on the wires, so either wire could be 12 volt or the control wire, but activation state should be low. Pulse width modulated frequency. This should be set at 30 hertz for a Mac 3-port boost solenoid. So it's already set here for 30. I don't need to do anything further here for setup and control. The voltage compensation is something I usually leave off. This allows a compensation factor to be applied to the control for the boost control solenoid based on battery voltage changing. There is a relationship between the voltage and a correction that is needed. I personally haven't seen enough of a difference to use the voltage compensation, so I always keep things simple and I just keep it off. And this is over a couple hundred cars I've tuned.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.